Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Chui Min Jun. Today, we will study Chapter 3, PLC Program-Controlled Punching on the Training Bench PLC Input and Output Modules. We will explore this topic from the following parts. Let's first look at the learning objectives of this lesson. We need to learn how to wire a PLC, make clear of the input and output ports, and become familiar with the sensors and actuators used in this project. 1. Components of the PLC control circuit. The PLC control circuit enables industrial automatic control through a programmable logic controller and consists of several fundamental components. First is the input unit, which converts physical signals from the field into electrical signals. Next is the output unit, which transforms logical signals into control signals. The CPU, as the core component, receives these signals, processes them, and sends out control commands. The memory is used to store programs and data. The power supply unit provides a stable power source to ensure the proper operation of the system. In addition, there is a communication interface used for communication with external devices. These components work together to achieve the automation of industrial equipment and processes. 2. PLC Input Module. In a PLC control system, the input module plays a vital role. It receives digital or analog signals from field devices and converts them into a form that the PLC can recognize and process. The input module consists of components such as input terminal, input filter circuit, photoelectric isolation circuit, and input interface circuit. These work together to ensure the reliability and stability of the signals. After discussing the input module, let's look at a key component, the sensor. Sensors in a PLC control circuit convert non-electrical signals from the field, such as temperature, pressure, flow, or displacement, into electrical signals. This enables the PLC to detect, process, and evaluate these signals, making sensors indispensable in PLC control systems. There is a wide variety of sensors, with common types including temperature sensors, pressure sensors, flow sensors, and displacement sensors. 1. Temperature sensors. Let's start with temperature sensors, which are used for detecting and controlling temperature. Thermocouples are a common type that measure temperature by generating a thermoelectric voltage at the junction of two different metal wires. Resistance temperature detectors work by utilizing the principle that the resistance of metal conductors changes with temperature. Thermistors are made of semiconductor materials, and their resistance changes significantly with temperature. 2. Pressure sensors. Pressure sensors are used to detect and measure pressure values. Based on their working principle, they can be classified into diaphragm type, elastic element type, and capacitive type. Diaphragm pressure sensors measure pressure through deformation of a diaphragm. Elastic element sensors convert pressure signals through the mechanical deformation of an elastic element. Capacitive pressure sensors reflect pressure changes by detecting variations in capacitance. 3. Flow sensors. Then there are flow sensors, which measure the flow rate of fluids such as water, air, or oil. Electromagnetic flow meters use Faraday's law of electromagnetic induction to measure flow. Ultrasonic flow meters calculate flow by measuring the speed and time of ultrasonic waves traveling through the fluid. Vortex flow meters measure flow using the vortex shedding effect. 4. Displacement sensors. Finally, displacement sensors are used to detect and control the displacement of objects. Potentiometers reflect displacement through changes in resistance. Hall sensors use the Hall effect to detect magnetic field strength and direction, enabling displacement measurement. Encoders measure displacement through photoelectric conversion and are known for their high precision and resolution. 3. PLC output module. Next, let's talk about the PLC output module. In a PLC control system, the output module is responsible for converting the control signals processed internally by the PLC into signals that can be recognized and executed by external actuators. The type and function of the output module depend on the actuators being controlled and the operating environment. Common types include electromagnetic relay output modules, transistor output modules, and solid-state relay (SSR) output modules. In addition, selection and configuration of the output module are important considerations. Actuators, as the key components in a PLC system that interact directly with the environment, convert the PLC's output signals into actual movements or operations. Actuators come in many types, with common examples including electric valve, pneumatic valve, electric motor, pump, and fan. 1. Electric valve. Let's start with the electric valve. It controls fluid flow using electric drive and is widely used in industrial process control. The working principle involves receiving digital signals from the PLC, which are then converted by electronic circuits into motor rotation. This movement drives the valve stem to adjust the valve opening. Electric valve offers advantages such as fast response, high precision, and convenient and reliable operation. 2. Pneumatic valve. Next is the pneumatic valve, which is similar to the electric valve but uses pressurized gas, typically compressed air, as the power source to perform switching actions. Pneumatic valve is simple in structure, low in cost, and easy to maintain. However, due to the higher viscosity of air, its response speed is slightly slower than that of electric valve. Therefore, in applications requiring rapid response, electric valve is generally more suitable. 3. Electric motor. Now let's talk about the electric motor, which is a commonly used actuator in PLC control systems to drive various mechanical equipment. There are DC motors and AC motors. AC motors dominate in industrial applications due to their good speed regulation and high efficiency. With control signals from the PLC, motor speed and rotation direction can be accurately adjusted, allowing for precise control of mechanical systems. 4. Pump and fan. Lastly, we have pumps and fans, which play a crucial role in fluid transport systems. The pump controls flow by adjusting the rotational speed or changing the outlet valve opening, while the fan primarily controls airflow by adjusting the blade angle. Their operating states are governed by PLC output signals, ensuring that the entire system operates according to preset requirements. For summary, that's all for today's lesson on PLC program-controlled punching on the training bench, PLC input and output ports. I hope you now have a clear understanding of the PLC control circuit components, including the input module, sensors, as well as the output module and actuators. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.